everyone for joining in. Good evening. I'll start with a brief introduction about myself, and then we can start with the session. Myself, Sagar Lad, I have total 10 plus years of IT experience, and currently I am working as a solution architect for one of the leading Dutch bank. I live in Amsterdam, Netherlands. So today we are going to talk about how we can implement near real-time analytics using Azure Synapse. So during the session, feel free to post your question in the chat, or if you want to speak up, unmute and raise your voice. I'll be happy to answer all the questions. And in case I won't, then I can also get back to you later on after the session. Yeah. So if we look at the agenda for today, mainly we'll be going to this like 2 points. The first one is introduction of Cosmos database and Synapse link, and how we can use the Azure Synapse link feature of Cosmos DB to create an end-to-end near real-time analytics with Cosmos DB and Synapse. And yeah, we'll take up Q&A at the end if there are any. Yeah, so let's start with the introduction of Cosmos DB and Synapse Link. Before we get into the more detail, I think first we have to understand the challenges and what kind of problems are being resolved by Azure Synapse Links for Cosmos DB. We'll also get an overview of Azure Synapse, and then we'll deep dive more into the end-to-end technical implementation. So, first of all, there are a couple of challenges when we talk about traditional analytics workload with Cosmos DB, which is one of the offering of Microsoft. So first challenge is manipulating the amount of provision throughput. So in Cosmos DB, we have basically two kind of throughput we can choose. We can manually provide the request unit for the processing, or we can also enable auto scale. But if it is not, if it is auto scale, then the cost of Cosmos DB is very high. And if we manually manipulate the provision throughput at the beginning itself, then there are possibilities that in case of more workload, we won't be able to process the data efficiently, or let's say read or write data efficiently with Cosmos DB. This is one of the bottleneck. Then the second challenge is using the change data feed to move data to Cosmos. So, in normal relational database, we directly work with a transactional record. So we do not maintain the history. But if there is a requirement where we want to maintain the history of data, then using the change data feature to move the data to Cosmos DB is a challenge. And then the third challenge is to develop the custom ETL mechanism to move the data to Cosmos DB. So even if let's say you are using if you are implementing one of the data platform solution where we have, let's say, ETL data factory pipelines in which you are doing some ETL transformation, and then if you want to move the data to Cosmos DB, you have to write a custom logic as per your preference, maybe in a Python or Java or any other language. But this is applicable for both batch and near real-time ingestion. But if you want to, let's say, as soon as there is a data in a landing zone, we should be able to make the data available immediately in Cosmos DB without any delays. Then that is not possible, or there are potential delays while doing the custom development. So these are mainly the bottleneck when we use the traditional analytics workload with Cosmos DB. Now let's see what is this Azure Synapse link feature for Cosmos DB and how it overcome all the challenges. So the first challenge it overcomes is enabling the analytics over the transactional data without impacting the transactional workload. So it will enable, so when we enable Cosmos DB for Synapse, then we will be able to support both transactional as well as analytics data uh, without any performance bottleneck. Then the second feature is Azure Cosmos DB Analytics Store. it allows to sync the traditional data into a columnar store. Then the third major benefit is no need to develop and manage complex ETL jobs. So because we are enabling with this Azure Synapse link feature for Cosmos DB, we can enable near real-time implementation, and from as soon as there is a data in the landing zone, the sign up links only make the data available to Cosmos DB. So we do not have to first of all develop any ETL code, and also we do not need any operationalization or maintenance of these ETL jobs. And the biggest advantage is we can make the data available in a near real-time manner. So we'll be able to perform near real-time analytics with the data that we want to, let's say, use, process, and bring some value for the business. Hmm. Yeah, so this is a brief introduction about Synapse Link feature of Cosmos DB. Before we further deep dive, as I mentioned at the beginning, let's also go through the introduction of Cosmos DB and Synapse offerings of Microsoft. And then we can go through the end-to-end implementation. So let's talk about what is Cosmos DB, what are the offerings, and how we can use it basically, or for which workload or which use cases we can use Cosmos DB. So Cosmos DB is Microsoft global distributed multi-model and NoSQL database. It has a lot of flexibility, and also from the performance point of view, it mainly allows us to elastically and independently scale both in terms of throughput and storage. And we can also enable geo replication to make the data available in Cosmos DB in a multiple region in case of any region failures. So it is Microsoft, like it is a NoSQL database, by which we can scale horizontally and vertically based on the workload and the configuration. And also there are other advantages, like it offers multiple APIs. So when we, let's say, try to spin up the Cosmos DB in the in the Azure resource group, you will have an option to choose different APIs. So if you want to use a document database as an in a NoSQL database, then there are two offerings, SQL API and the MongoDB API. If you want to work with a key value data pair, then you can use the table API. If you want to work with a columnar database, then you can use Cassandra API. And if your application or a use case wants to use a graph database, then you can use Gremlin API. So these are different type of offerings when we want to use Cosmos DB with Microsoft Azure. Based on your workload and the need, we can use different API. And then there are also other benefits, like we can enable near real-time implementation if we use Synapse Link feature of Cosmos DB. It has complete integration with application insights and other services. So if you want to, let's say, understand the performance, if you are facing any bottlenecks, or if you want to see how the processing happens, or there are inbuilt monitoring dashboard we can use to closely monitor the Cosmos DB workload. Now, Cosmos DB, it mainly allows us to build an application which is highly responsible and available applications worldwide. Highly responsive in the sense that we can make the data available very quickly in a near real-time manner, and that can be used for the consumption purpose for various reasons. And while configuring or creating Cosmos DB, we can also enable geographic replication. So it is highly available application which can be used worldwide. It also, apart from this, it also ensures that our the end users data is as close as to them as possible, with a guaranteed low latency for both read and write at the 99 percentile. So if we enable geo replication, and if your application is a worldwide application, we can, let's say, configure geo replication for Cosmos DB, and uh, we can try to consume the data from Cosmos DB from the nearest location, and also it offers lowest low latency. Now, when we talk about Cosmos DB, there are, I mean, it also provides us a more flexibility. to make a choice on what kind of consistency model we want to choose. So Cosmos DB as of now provides 5 different type of well-defined consistency: strong, bounded stillness, session, consistent prefix, and eventual. So these are a different type of consistency being offered by Cosmos DB. And based on our workload and the requirement, we can choose one of the consistency model for read and writes from the Cosmos database. This is a brief introduction about Azure Cosmos DB. Now, let's also deep dive further into what is the Synapse offering, what are the features, and how we can use the combination of Cosmos DB and Synapse to make our near real time implementation much easier, simpler, and flexible. So Azure Synapse, as we all know, I think most of us who are working with data analytics projects, Synapse is an integrated analytics service which actually allows developers and end users to use SQL and Spark for their analytics and data warehousing workload. So it is a unified platform in which we can do our development in SQL. But if you have a need where you want to create a distributed application with more performance improvements or more performance optimizations, then we can also use Spark on the top of it. So it provides a SQL pool and a Spark pool. When we create a Azure Synapse server, once the Synapse server is created, you have a freedom to create those server pools and then do the development on the top of it. Now with Synapse, we can build the pipelines for data integration, a machine learning purpose, ETL or ELT workload. Now, the major advantage of using Synapse is it has full integration with other services or a component. So basically, we can leverage all the Azure components to build our end-to-end, let's say, data analytics project chain, starting from collecting the data, doing the ETL or ELT on the top of it. And once data is available in a golden layer, it has connectivity with tools like Power BI, where we can create Power BI visual reports, or if you want to create a machine learning model or any advanced analytics activities. It also offers an integration with Azure Machine Learning Service, Power BI, and Cosmos DB. So we are now going to, in this session, we are going to explore the feature of integration with Cosmos DB for Azure Synapse Link. Now, apart from this, Synapse also provides us with a unified management, monitoring, and security over the enterprise data lake. Uh, it has complete integration with ADLS Gen 2 or let's say blob storage, so we can also securely access the data. It is a unified platform, as I mentioned earlier, so we can collect the data, process the data, and also create visual reports or a KPI reports. And apart from this, from the ops point of view, we can also do monitoring. So with the help of Synapse Studio, mainly it enables data engineers, BI engineers, and data scientists a unified experience to build the complete analytics solutions. So in a traditional, even in a traditional or in a cloud data analytics workload, most of the people are working in a silos. So data engineer works on Python application or a PySpark application to create an ETL logic. Then there are data analysts who work on the data created by data engineer to create some insights. So they are working with different tools, and when we work with different tools and when we work in a silos, there are multiple challenges like data prepared by data engineers may not be relevant or compatible with the tool that data analysts are using it, but Azure Synapse overcome these challenges by providing a unified platform. So basically, all different type of roles can work on the same platform. So there is no data compatibility. There are no challenges with let's say schema or data requirement. So this is we have now understood the basics of Cosmos DB and Azure Synapse offering. Now let's see what is this feature of Synapse links for Azure Cosmos DB and how we can use it to create a real-time streaming application. So the Synapse link for Cosmos DB is a cloud native capability. It is at step basically hybrid transactional and analytical processing. So if you want to work with a workload where we have a requirement to work with both transactional and let's say warehousing processing, then this is the feature that we can use with Cosmos DB. Now, with this Synapse link for Cosmos DB, we can actually create and run the near real-time analytics over the data in Cosmos DB using the Cosmos DB Analytics store. So once the Cosmos DB is created, yeah, first of all, we have to enable the Synapse link. And with this Cosmos DB Analytical store, we can enable near real-time analytics or an implementation. Uh, Then with Azure Synapse links, it provides a way to perform near real-time analytics on the data without having to create any ETL pipeline. So basically, normally in a normal workload, or even if we take an example of cloud workload, if we want to create a near real-time application, we need to do a lot of development, and also we need to have a platform capability. So let's take an example of Kafka. Kafka Confluent is a near real-time streaming platform. So let's say if you want to enable near real-time ingestion using Kafka platform, then first of all, we have to make the data available in ADLS Gen 2. From ADLS Gen 2, we have to create a data factory pipeline under which we can have a Databricks notebook. Now this Databricks notebook can publish the messages or new updates to the Kafka topic. And then we have to subscribe to this Kafka topic and create a custom development, maybe in Python or any other language, to consume the data in a real-time manner. But with the Synapse link for Cosmos DB, basically we can avoid all this complexity without having any additional platform capability or without doing any additional development at a sync connector end. We can get the data in a near real-time manner on the top of Cosmos database. So this is the, let's say, the oral flow. We have Cosmos database, maybe with one of the API, SQL API or a Cassandra API or a MongoDB API. There we have data stored with some features, with some indexing. Now on the top of this Cosmos DB, we can enable Cosmos DB Analytical Store, which try to convert all the data from row-based indexes to the column-based indexes. And then we can use Synapse Analytics to directly, let's say, consume the data in a near real-time manner from Cosmos DB. Apart and along with this, we can also leverage other features like reporting or integration with Power BI or other tools. So this is the Azure Synapse link feature of Cosmos DB. Now, there was a new term, right? This Cosmos DB Analytical Store. So let's also understand in detail what this feature is about and how it will enable us to enable near real-time implementation. So Azure Cosmos DB Analytical Store is an isolated column store, which mainly allows us to perform analytics against the transactional data without impacting the transactional workload. So let's say in a traditional database implementation, what happens is there are like multiple applications who are dumping or writing the data to SQL DB, and at the same time, let's say if we are also reading this data for a tool like Tableau or Power BI, then we see a lot of performance challenges. But with this Cosmos DB Analytical Store, without impacting the transactional workload or a transactional read or write, we will be able to perform the analytics efficiently without any, let's say, less delays. And let's say we can create those visualizations very quickly or without any performance delays. So transactional store is a row store which is optimized for transactional reads and writes. So it will optimize the reads and writes which are happening to the transactional workload. Then one of the major advantage of this Cosmos DB Analytical store is it is schema agnostics, and it allows us to iterate over the application without having to manage the schema and indices. So in a normal relational database, before we make the data available, we have to create the schema. And in case of any schema drift or a schema evaluation or schema changes, first we have to change the schema. and then we have to, let's say, then only we can ingest the data to the database. But the Cosmos DB, as it is a NoSQL database, it is a schema agnostics, and it is also able to handle the schema drift. And apart from this, we do not have to additionally apply the indexes. It is internally, it will do all the optimization by itself. Then with this analytical store, it also helps us to perform the super fast transactional reads and write on the top of Cosmos DB. So as we discussed at the beginning, Cosmos DB offering has two plans, like we can provision the throughput or request at the beginning itself, or we can also enable auto scaling. But if we want to do a trade-off to reduce the cost based on your application, then I mean, without impacting or without provisioning more request unit or auto scaling, with this feature, we can also quickly read and write data to Cosmos DB. Now, apart from this, we can also extract the data out of Cosmos DB in a separate layer that is more suitable for to perform the analytical workload using the chain data feed. So, for example, if you want to, if we can spin up Azure functions to listen to the containers of the Cosmos DB for the insert. So whenever there is an insert or a new insert into the Cosmos DB container, then we can also, let's say, quickly using the change feed. So it will automatically monitor the changes happening in the Cosmos DB container, and then we can maybe make the data available in data lake store or a blob storage, or if our target is to move the data to a different, let's say if you want to create a Databricks delta table, then also it is possible. So we can spin up with the combination of Azure functions, we can closely monitor all the changes which are happening to the Cosmos DB. And based on the required scenario, we can also enable the post-processing action. So these are the features of Cosmos DB Analytical Store. As apart from this, what Analytical Store does is it is a column store. So it is mainly optimized to perform the analytical queries. So this way we can reduce the latency of reading the data from Cosmos DB. And then we can use it to work on different use case or a scenario for the downstream consumption. With Cosmos DB Analytical Store, it can also sync the operational data in the row store in a separate column store, which can help us to perform the analytical queries without building any ETL pipeline. So no custom development is needed. Then when we enable this analytical store, basically it is an isolated column store which is created based on operational data inside the transactional store. So they both will be persisted separately. Data is automatically string between both operational and transactional store, and we do not have to use the change feed or develop our own ETL mechanism. So let's say uh, if there is a requirement where we want to maintain the history of data, then we do not have to do any custom development. It will all the syncing will be done automatically, and the latency of the syncing is around 2 minutes. Then autosync will occur regardless of intensity of the traffic. So there won't be any impact on the performance of your application. The syncing will happen in the background independently. So that way it provides more flexibility, and we do not have to worry about any performance challenges. Now, in analytical store, basically there are two modes of schema representation. So we have well-defined schema, and we can also choose full with fidelity schema representation. So what do we mean here by well-defined schema is it is a tabular version of the data in a transactional store, while the full fidelity schema handles the full breadth of the schema that exists in the transactional data. So these are the two offerings that we can select while creating the analytical store. So that this is mainly briefly about this. What is this Cosmos DB analytical store? Now coming back to the main feature by which we can enable near real-time implementation is enabling the Synapse link. So first of all, the prerequisite before we start with this implementation is that the Cosmos DB should be present in your resource group. Azure Synapse server should also be present in your resource group. Now, once you create the Cosmos DB, uh, we can go to the Azure portal. So on the left hand side, you'll be able to see the container and also the different components that you created inside the container. And on the top pane, you will be able to see this kind of pane. So from this pane, first of all, so once the Cosmos DB is created, we have to go to the Data Explorer. And once you click on the Data Explorer, you will get this screen along with the container details and the underlying files. So we have to click on a button, enable Azure Synapse link. So once you click on it, then it will take few minutes to take effect. And once it is done, we have to set up the analytical store for the container, which we will look into the next slides. So once we click on enabling the Azure Synapse link feature, we have to set up the container to use the analytical store. So uh, we have to go to the Data Explorer, click on a new container. Now, once you set up a new container, we have to provide the name, partition key, and throughput configuration as per our requirement. Now, the essential thing here we have to notice the at the bottom there is a feature where you can turn off or turn on the analytical store. So once you create a container, you have to provide a container name. You have to provide the partition key, the throughput, whether you want to enable auto scale or a manual. And even if it is auto scale, then until which maximum RUs you want to provision, let's say. So here we can specify the maximum request units. And there is a feature to enable analytical store. So this is a must. Once you enable the Synapse link, if you want to use that feature, then you have to also enable the analytical store. Now, once that is done, it will create a container basically. So once the container has been created, you can see this kind of look where, let's say we can configure different options. So this is the Cosmos DB container. We created a Cosmos DB with SQL API. Under the device DB container, we created this device readings. And when you click on this device readings button, because we have enabled Synapse link and analytical store, you have option to set this feature. So time to live feature, geospatial configuration, and analytical storage time to live. So based on the requirement, we can also enable these features. And we will also deep dive further into what this feature is all about and how we should configure it to meet our project needs. So first one is analytical time to live. So time to live feature for analytical store mainly describes how long we want to keep the data in the analytical store. This setting is isolated from the time to live setting that we have for the transactional store. So as we discussed, we have two type of stores. We have operational stores and we have transactional store and we have analytical store. So we can only for analytical store, we can specify this feature to make sure how long we want to retain the data. Now, since both the settings are isolated, data archiving becomes very simpler for us. So analytical store is optimized in terms of storage compared to the transactional store. Apart from this, we can also retain the data for a longer period of time by setting this feature. So if we have a need where, let's say same data is being used by multiple consumers or a multiple downstream application, then we can enable this feature for a longer period of time. So every time whenever there is a read, we do not have to go to Cosmos DB and then fetch the data. So it is kind of a catching mechanism. Now, once we enable this feature, the next step is to connect the Cosmos DB to Synapse link, right? So we have a container on which we have enabled analytical store. Now we want to connect the Cosmos DB. Now we want to connect this container to a Synapse workspace. So if you do not have a Synapse workspace, then the first requirement is to create a Synapse workspace. You can follow the link to create a Synapse. Now, now one if the Synapse is created, then we have to open the Azure Synapse Analytical Workspace. Once you open it, you will get this kind of UI or a screen. And from this screen, we want to connect to an external data, right? So we have to select the data section, and from the data section, you have to connect to the external data. So once you click on the XML data, you will get a screen where you can choose different type of connectors. Let's say if you want to connect to blob storage or a Cosmos DB with Mongo API, SQL API, Data Explorer. These are various type of connector that we can use. So at the time of preparing this deck, actually, we can connect Cosmos DB account. We can connect from Synapse to Cosmos DB account only via SQL DB or MongoDB. Now, if we have a globally distributed Cosmos DB account, then an analytical store will be available for the container in all the regions. And any changes in the transactional store, it will be replicated to all the regions of the Cosmos DB account. So once based on, let's say if we have spin up Cosmos DB with MongoDB API, then we can select this connector Cosmos DB with MongoDB API. And as soon as you click on a button, you will get an option to create a link service. Like in Data Factory, also we create a link service for a point-to-point connection. Same way here, we have to create a link service. So you have to provide a link service name, description, integration runtime, whether you want to connect via self-hosted integration runtime or auto-resolve integration runtime. Auto-resolve integration runtime is a compute provided automatically by Microsoft. So for most of the workload, we can use this auto-resolve integration runtime. And in the connects, so in order to set up a connectivity with Cosmos DB, you can explicitly specify the connection string, or you can, if have your connection string stored in the keyword, then also you can configure it with keyword. As of now, I'm directly specifying the connection string. So from Azure subscription, we can select the subscription name and the Cosmos DB account name, and then we can specify the connection string. So once all the details are okay and validated, the link service will be created, and on the left hand side of the Cosmos DB on the Synapse server, you will be able to see the link service which we created now. Now, as we discussed, like we have different type of containers, right? When we enable Synapse link for Cosmos DB, so we can differentiate between what these two containers are, like analytical store and the transactional store. So in OLTP, in on for transactional store, we only have container. For analytical store, we need to create an Apache Spark pool, and to do this, we have to create a managed pool. So first of all, we have to create Apache Spark pool in the Synapse server. So this is the screen that you get. So once you click on the analytical pool, if you want to work with a SQL workload, then you can create a SQL pool. If you want to create a Spark pool, then you have to work with a Spark pool. And this is the component where we created the link service. If you want to enable any triggers, then also, yeah, we can create a trigger. Now coming back to creating a Spark pool, so we have to on the left hand side click on Apache Spark pool button, and if you click on a new, then you will be able to create a Spark pool. Now, once you click on a create button, you will get a screen where we need to provide this information. So you have to provide the Spark pool name and the node size. So if we are dealing with small data, then the small is sufficient. But if we have a more workload, then we can choose based on a configuration. Auto scaling feature should be enabled. It is recommended to also save some cost and make your application highly available. And once, let's say, all the informations are inputted and validated, then yeah, it will create a Spark pool. As you see, the Spark pool has been created. And if you want to, let's say, permanently save this change, then you can click on a publish all. Then even when you log in for the next time, or there are other developers in your team, they will also be able to use this Spark pool. Now let's also deep dive further into how to work with the analytical store in Synapse. So this will be, I mean, we are now starting with I mean, first of all, I'm just explaining you what kind of data is available in Cosmos DB as of now, and then how we can use it to enable near real-time streaming. So there is a sample device reading container. It has 10,000 documents, and each document contains this kind of structure in a key value pair. So we have ID, we have temperature, damage level, age in days, and location. Now let's try to query the data using Spark, the Spark pool that we created in Synapse. And when querying the data, we can either load the data to Spark using the data frame, or we can also create a Spark table. Synapse Apache Spark enables us to query the data in Cosmos DB without impacting the transactional workload. And we can also ingest the data to Cosmos DB using this Spark pool in a streaming manner or in a via CQRS pattern with both Cosmos DB as a sink and a connector. So let's say once the data is available in Cosmos DB, this is a simple command. So we are, at least for this demo, we are going to load the data using the Spark data frame, PySpark data frame. So data frame using spark.read format. The format is cosmos.olf because the data is stored in analytical store. This is the option. So option for the link service. So the link service has a connection string to Cosmos DB. Using this link service, it will try to set up a connectivity. And here we can provide an option from which container we want to read the data. So once we, let's say, run this data frame, the data will be the data frame will be created, and we can use this data frame further to make the for the real-time streaming. So once we run the, let's say, once we run this command in the notebook, the data frame will be created, and this will be the content of the data frame. So temperature, damage level, age in days, and location. Now we want to perform some ATL on the top of it, or let's say for an example, we can execute the query where we want to drop few columns. So we can it is a simple, let's say, PySpark command where we are dropping these three columns, and as soon as we drop the column, then we'll be able to directly see the changes in the Cosmos database with only relevant columns. So now we have prepared the data frame. So now we can use Synapse to perform the analytics. Now, one thing we have to notice, we can run the target analytical store, meaning that the queries have no effect on the transactional workload. So in our data frame, we have a column for how old the device is in a day. So there is a column called how old the device in a day. Now let's see which one are the oldest columns and what kind of damage they have sustained in the field. So from the data from the df underscore clean database clean data frame where we have removed certain columns, uh, we are, let's say, first of all doing the order by based on age in days. So we in a descending order. So it will, let's say, create a list of entries with the device which is the oldest at the top and the newest at the end. Now we want to display only, let's say, 10 records or a limited record. So we can display by using this command. Now, the point to note here is I'm here in this session, I'm just demonstrating the capability of able to run the query on the top of analytical store using Cosmos DB Spark in Synapse without affecting the transactional workload. And but this is not only limited to the using the query in the this is not only limited to query the data in Spark. We can also query the data in T-SQL using the serverless SQL pool. So there are two pools, right? We have SQL pool and we have Spark pool. So even if you are more comfortable with SQL and if you want to do the data processing or work with data using SQL queries, then also it is possible. So in Synapse, we can set up the SQL pool and then work with the SQL queries. Now, if you are following this, I mean, when you want to do the hands-on, if you are working with your personal sandbox or a resource group, then the recommendation is to immediately, let's say, I mean, we can quickly provision the serverless SQL pool or a Spark pool based on our requirement. But once the setup is done, maybe you can turn it off to reduce the cost. Now, now we understood the advantage of using Synapse Link for Cosmos DB, but it also have, I mean, let's also understand from the cost point of view how costly it is or how the costing or pricing is being calculated. So when using Synapse Link for Cosmos DB, mainly we have to pay for both analytical store as well as the processing or a compute that we use in Synapse. So it is not, I mean, the cost will be calculated based on your usage, but it will be the cost will be calculated for both Cosmos DB feature as well as the processing power in Synapse. Now, Analytical Store also follows a consumption-based pricing model. So we will be charged based on the storage retained in the Analytical Store and the number of read and write operation that we do on the top of Analytical Store. So since the pricing is separate from transactional store, we do not have to provision any additional request unit. So for if you, let's say, only when you want to do the processing with transactional store, you do not have to worry about any performance, or you do not have to allocate any additional request unit. So this is how the pricing works. There are also some limitations of using this feature. So one of the limitation is currently Synapse link for Cosmos DB is only available for SQL and MongoDB API. We cannot use it for Cassandra API and Gremlin API offerings of Cosmos DB. For any containers with the analytical store enabled, automatic backup and restore of data is not currently supported. So basically, if there is a need to restore the transactional store, then the container will be restored without the analytical store enabled. So that is the one of the limitations. Yeah, so that's the end of the session that I want to present today. If there are any queries or any points to discuss, I'm feel free to open and share. Yeah, do we have any questions in the chat?
A few thank yous. Like Patterson's writing something. Here's a question. Did you say?
Yeah, so there is a question from Michael. So as of now, Michael, there is no support of Cosmos DB Gremlin API for the Synapse link, but it is on the roadmap of Microsoft, but I do not have the timelines as of now. Yeah, there is one more question from Mike Roma. So yes, so the question is, does Synapse allows pulling data from on-prem SQL database? The answer is yes. So in Synapse, we have gone through the process of creating link service. So in link service creation, we have two options. We can use auto resolve integration runtime, or we can also create auto resolve self-service integrated runtime. So if we use this feature, then we can also get the data from on-prem SQL database by creating the self-hosted integration runtime link service. Yeah, I think I don't see any further questions. So over to you, Jason and William.
Great. Sega, thank you very much. Very informative talk. Deep dived in a few topics that I'd only superficially learned about. So appreciate that. The YouTube video will usually show up about a day later on, and I'll post in here the coordinates of that. It's basically youtube.com/ Boston Azure. And I guess that's a wrap. And keep an eye on the usual spaces for more events. We have a couple more coming. Actually, Veronica, did you want to say anything about the next couple before we kick people out?
Yeah, I mentioned in the beginning that we are currently planning 2 events in February. I am creating them right now in Meetup. So one is going to be on the 7th and another is going to be on the 28th. So definitely check our Meetup pages for both Boston Azure and North Boston Azure. And then we'll also post all the information in our Twitters.
Okay. Thanks again, Segat, and thanks again, everybody, for joining, including from Nigeria and a bunch of locals. And thank you for the long distance call in, Segat. Have a good evening and a good
Yeah,
day,
thank you
everybody.
everyone. Bye.